Hi there, in today's video we're going to actually be starting a new topic today where we're going to be introducing what the trigonometric graphs look like. Okay, so up till now we have only used sine, cos or tan during your high school time as buttons on our calculator to get the length of a triangle, work out a missing angle, or maybe the area of a triangle like we've seen this year. However, what we've not done is we've not really had time to discover what sine, cos or tan actually are, or what they even look like. Okay, but we will today. So we're going to start with the sine function. Okay, so sine, cos and tan are all functions with unique graphs. Okay, but in order to sketch them, we're going to need to get the values at certain points. Okay, so during this video, there's going to be a lot of times I'm going to ask you to copy tables down and copy graphs down, okay? So please make sure that you are pausing this video in order to do so. So the first thing I'm going to ask you to copy down is this table of values here. So I'm going to work out my value of sine at all these points here, okay? So I went up in stages of 30 degrees, starting from 0 all the way up to 360 to see if I can work out what picture the values will give me so that I can picture the graph for a sine curve. Okay, so starting at 0. Okay, so if you work out what sine of 0 is, okay, if you put it into your calculator, you get the value 0 out. Okay, so there's my first entry in there. Sine of 0 is 0. Okay, if I go sine of 30, then I get a half, so that's 0.5. If I then put sine 60 into my calculator, I get 0.866 continued. Okay, and if I go up to sine 90, I then get the value 1. Okay, so sine 90 is exactly 1. Okay, if we continue, so sine 120, then it takes us back down to 0.866. If I put my calculator sine 150, you get 0.5. Oh, let's try that again. 0.5. And if I then try sine 180, I then get 0. Okay, so I'd like to pause this video just to check that you're getting these same values. Okay, if you're getting the same values, continue. If not, check your calculator again, make sure it's in the right mode. Okay, it should be in degrees, just have like a little D symbol at the top as opposed to an R or a G. And you should be getting these values in your calculator. Okay, so remember, all the numbers at the top row are the values I'm putting in. So I'm putting sine of 0, which I got as 0, sine of 30, and I got 0.5, and so on. Okay, we're going to continue because I want to see what happens past 180. So if I put sine of 210, I get negative 0.5. Okay, so my value actually starts to go to the negative side. If I then continue go sine 240, I get negative 0.866. If I then go to 270, it then goes to negative 1. And then sine 300 gives me the answer negative 0.866. Sine 330, negative 0.5. And sine 360 is back up to 0. Okay, so that is me worked out all the values of my sine graph at these points here. And what I'm going to do is I'm going to plot these so I can get a full picture of what it's actually doing here, because there's a lot of numbers that are the same, but some are positive, some are negative. It sort of goes up, it goes down. Let's see exactly what happens here. So again, I'm going to get you to sketch this. So we're going to title this y equals sine x. The first thing we're going to like to do, I'm going to get you to draw a set of axes. Okay, so again, this is our x-axis. Up here is our y-axis again. Now, what I'm going to ask you to do is I want you to have your origins mostly at the left-hand side of your page. Okay, so that is my origin here. Now, for some reason, this is just acting silly. There we are. And that's going to be 0.0. Okay, that's my origin. I want you to draw 3 boxes up and 3 boxes down. Okay, and then I want you to actually draw, if you've got box paper, which is preferably for this case, 12 boxes along. Okay, we're going to go 12 boxes along. The first thing we're going to do is we're going to put in the key points here. So the key points are 0, okay? The next key point is 90. Our next key point is 180. And our next key point is 270. And the last key point is 360. So all of them are degrees, okay? So what I've done is I've spaced them out so that there are 3 boxes along each. So I'll go 3 boxes along and that's 90 degrees, another 3 boxes along 180 degrees, another 3 boxes along 270, and another 3 boxes up the end, 360 degrees. And what I'm going to do is I'm going to plot the coordinates at this point here. Okay, so sine of 0 was 0. Okay, so this graph's actually going to start at my origin. I've got 0, 0 to start with. Okay, sine of 0 is 0. If I go along to 90, sine of 90 is 1. Now what I'm going to do is 1 is actually the tallest this graph gets. So I'm going to go up to my 3 boxes here and I'm going to put a value 1 there. This curve actually has a lowest value of negative 1. So I'm going to put that down 3 boxes and put negative 1 there. Okay. So if I go along to 90, sine of 90 was up at the value 1. So I'm going to just put like a wee line there to say that's going to be a coordinate point there, okay, for me. Then I go along to 180, work out what sine was at 180. So from my table, when I was at 180, sine was 0, so I'm back down at 0. If I go to 270, it was actually all the way down at negative 1, so it's going to go along down here. And back up to 360, the value was at 0 again. Okay, so you can see from 0, it goes up when it's at 90, goes back down in the middle, goes down to 270, and goes up to 360. The question is does it go up in a straight line? Does it curve? Okay, does it wave about? Let's see. Okay, so if I've divided this up into 3 parts up to 90, then the first box will be 30 degrees. Okay, so that is halfway up because sine of 30 is 0.5. Okay, so that's going to be halfway about there. Okay, if I go along to 60, which would be this box here, it's 0.866, which isn't that far away from 1. Okay, so we'll put that there. Then after 90, 120, it's back down at 0.86, so it's back down there. Sine of 150 is 0.5, and I then get to 80. Okay, so you can probably see that this is not going to be a straight line because a straight line wouldn't match. Okay, it's going to curve up towards this. Okay, if I continue with this graph, though, 210 is down at negative 0.5. 240 is down at negative 0.866. 300 is at negative 0.86, so it's closer to negative 1. Sine of 330 is negative 0.5, so again halfway down my y-axis, and sine of 330 is there. So you see I've got this sort of curved shape. Now this is going to be very difficult for me to do on a tablet. Okay, I will try my best though. This curves like that. That's the best I can sort of do. So up and down, it goes a bit more like that, and if I continue, it goes down and curves back up. So sine is actually a smooth curve function, okay? And the key thing about sine, okay, we're going to look at cos and tan, some of them are similar, some are different, is the key thing with sine is the following, the key points, okay? So the key points are 0, 90, 180, okay? So the key thing is, okay, for a sine graph, is that it starts at 0. Okay, so a sine graph starts at 0, okay, doesn't have any height. Okay, at 90 degrees, it is 1. Okay, we get the value 1. Okay, 180 degrees, we're back down to 0. 270 degrees, we are at negative 1. And 360, we are back up at 0. Okay, so those are the key points there. Okay, so sine starts at 0, it goes up, comes back down in the middle, goes further down to negative 1, goes back up to 360. Okay, right, couple of key phrases we're going to introduce now. So, sine graph, okay, it has a maximum at 90 degrees. Okay, so the tallest a sine curve gets is at 90 degrees when it equals the value 1. Okay, it has a minimum value at 270 degrees when it's at negative 1. Okay, now key phrase as we're going to use is the period of a curve. So what you'll notice is that this curve, if I continued this, so after I went across 360, it would repeat itself. Okay, so it goes up, down, goes up, starts 0, goes up, goes down, all the way down to negative 1, back up to 360, and then it would do the same. It would then go back up, middle, down, back to middle, okay, and it would just repeat itself endlessly, okay. However, what we sometimes want to know is how long does it take for a full cycle to go, okay, so for a sine graph, when it starts at 0, how long until it goes back up, down, all the way down, and then back up, so that it's going to start again, okay, and that's what's called the period. So the period of sine of x is 360 degrees. Okay, it takes a full 360 degrees for its cycle to travel. Okay, so that's what the sine graph is. That is how we plot it. Okay, the key thing is once you've got that plotted down in your notes, you understand that a sine graph has that look about it. Okay, where it starts at 0 and goes up. What we're going to do now is we're now going to move on and look at what the cos graph does. So again, I like to pause the video, create a new table so that we can put in our cos values here. Okay, I will go through this a bit quicker. So again, key points, okay, 0, 90, 180, 270, 360. But we want to know what it does in between so we can sketch it. Okay, so cos of 0, so put cos in your calculator and put cos of 0 in. You get the value 1 this time. Okay, cos of 30, 0.866. Cos of 60, 0.5. Cos of 90, you should get the value 0. Okay, continuing that, cos of 120 is negative 0.5. Let's type that in properly. There we are. Cos of 150 is negative 0.866. You should be checking you get these in your calculator too. Cos of 180 is negative 1. Okay, continuing, cos 210. Okay, we're back at negative 0.866. Cos of 240 is negative 0.5. Cos of 270, we're back at 0. Okay, continuing, cos of 300, okay, 0.5 again. Cos of 330, 0.866. And cos of 360, we are back up to 1. Okay, so there are values that you should get in your table. Okay, check if you get them. Then what we're going to do is that we're going to sketch the y equals cos x curve here. So again, key point says we're going to draw the exact same grid. Okay, so you're going to start at the origin. Okay, I want you to draw, well, better not write that in blue actually. Let's try that again. Oh, I didn't realise it was going to do that. Let's just be a little bit more careful when it comes to this. Let's try this again. There we are. Okay, so starting off at the origin. 3 boxes along 90 degrees, 3 boxes along 180 degrees, another 3 boxes along 270 degrees, and another 3 boxes along 360 degrees. Okay, so you're drawing your line across here, your x-axis, 12 boxes along. Why? Same again, you're going up 3 boxes, down 3 boxes. The biggest cos got was 1, that was the biggest value that we got, and the lowest cos got was negative 1. So we're going to look at our graph and see if our data can help us work out what happens. So starting off at 0, well, cos of 0 wasn't 0 this time, cos was actually 1. Okay, so if I put cos of 0 in, I'm actually up at the top here already, cos was 1. Then at 30, sorry, we'll do the key points first. Then at 90, it was down at 0. Then at 180, we were down at negative 1. Then at 270, we were back up at 0. And then up at 360, we were back up to a value 1. Okay, now what we're going to do is we're going to draw the first half of this is to show you that you're going to get a curved sketch again like we did. Okay, this won't be straight lines like before. So cos of 30 was at 0.866. Cos of 60 was a half, so halfway there. So therefore you'll see it won't be a straight line, takes me to 90. It's going to have to be curved. Then cos of 120 was negative 0.5. Let's try that again. Cos of 150 was negative 0.866. Okay, so we're going to get a curve. So my curve's going to look a bit like, oh, not like that. Let's try that bit again. This is where I wish I was doing it on my board, folks. And we get there. Okay, and what actually happens is we're going to get a curve that goes like that. Okay, so you see it's not quite straight, but it is a curve, and you can see this would continue again. Okay, so once I got to 360, if I wanted to go further along, okay, so go up another 30 degrees and another up to like the next sort of increments, it's going to then curve back down like what the first graph done. Okay, so that is what the cos graph does. Okay, so again, we're going to talk about the key points for cos. Okay, so it's very similar to sine. We had a lot of the same values in our table. However, there was a few differences. Okay, so the main one is it starts at the value 1. Okay, so in cos of 0, is, sorry, when you put cos of 0 in your calculator, we actually get 1, so it starts at 1. Okay, at 90 degrees, we are at a value of 0. Okay, at 180 degrees, we're actually down at -1, and at 270 degrees, we're back up at 0, and 360 degrees, we're back at the start of my function, which was back at the height of 1. Okay, so those are the key things there. It does have some similar properties. So again, if we talk about the minimum and the maximum, so the minimum, sorry, we'll do the maximum first and the maximum last time for the sign. So the maximum for a cost graph is 1 again, but this time it happens at 2 places, at 0 degrees and 360 degrees. Okay, the minimum, let's write that, minimum is at -1, so that's the lowest it goes, a bit like a sine graph. However, it happens at a different place. It happens at 180 degrees. Okay, so you can see from the cost graph that you've drawn that the lowest it gets is -1, and that's at 180 degrees. Okay, period of the graph. Okay, so the period is from when it starts to when it completes itself, and then it would repeat itself. Okay, so we started at 1, and it took us 360 degrees to go back up to a height of 1. Therefore, it will start again, so the period again would be 360 degrees. Okay, so those are the sine and cos graphs, folks. Please make sure you spend time pausing the video and writing these down to make sure that you have got these values and that you have got graphs very similar to mine, so that you can understand what both look like. They're very similar, they just start at different points, but they have a lot of the same features. Okay, the maximum minimums are the same value, but again at different points too. We're going to look at tan graph now. Tan is the exception now. A wee heads up, when you see the final product of tan, you might not like the graph as much as the first two. The good thing is you're very rarely going to be asked to draw a tan graph. Okay, it's normally sine or cos, therefore I don't want you to worry too much, but it's important that you understand what a tan graph looks like so that you can spot it if you were asked for it. So again, putting in our values first of all, you're going to see we get actually some different values here. So you get 0.577 when tan is not tan of 0, so that's my mistake, my apologies. Tan of 0 starts at 0, okay, that's where it starts. So a bit like sine, starts at 0. But then when we go up to 30 degrees, it's still a different value, it's now 0.577. And then at tan 60, it is actually bigger than 1, it goes 1.73, so that's already a change, we're actually higher than 1 already. Tan of 90, if you type tan of 90 in your calculator, you will end up with a math error. Okay, and I'll explain a bit more to you why that is the case later on in the course. However, that is just all you need to know at the minute, and I'll explain what that means for your graph too. So we'll keep going. Tan of 120, then you're down at -1.73. Okay, so you're going to see at tan 150, I get -0.577, and then at tan 180, I've got the value 0. Okay. 210, okay, so it sort of repeats itself. I've got 0.577, 240 is 1.73, tan of 270, again if you type in your calculator you should end up with an error, that's not a mistake, okay, so there's not a value at this point, okay, and 300 degrees, it then takes us back down into the negative, so negative 1.73 and negative 0.577, and tan of 360 back to 0. Okay, so this one does have a bit differences. The key one is the differences are we actually have points in the graph where we don't have an answer. Okay, tan of 90 doesn't give you an answer, you end up with an error. Okay, so again what we're going to do is we're going to sketch the tan graph. Okay, so starting off with your origin. Okay, make sure I'm writing this in the same colour now. Starting off with your origin, then I'd like you to go 3 boxes along on 90 degrees again, another 3 boxes along 180, another 3 boxes 270, and another 3 boxes 360. Okay, so tan of 0 was 0, so we're actually starting at 0 this time. Tan of 90 was error. Now what that means is there's this part of the graph there's no solution. So when we have no solution at this point, what we're going to do is we're just going to draw a dashed line so that we know our graph is not going to hit this dashed line here. Okay, tan 180 is back at 0, tan at 270, again we had an error, so we're going to have another one of these dashed lines. Okay, and tan of 360 is back at 0. Okay, so what does this graph look like? So tan of 30, well, that was 0.577, so we're actually quite high up there. Now what I'm going to do is I'm going to modify my graph slightly here. I'm actually going to put my 1 and my -1 more condensed because I know what's going to happen. I'm only going to put that one box up and one box down each, okay, so you can see what happens here. So tan of 30 degrees was 0.577, so slightly over half. Tan of 60 was 1.63, okay, so 1.73, sorry, so actually that goes up there. So what actually happens is this graph at this point curves and it goes all the way up and it starts shooting up, okay, and if you want to test that in your calculator, do tan of 89. You see tan of 89 actually gives you a really big number, okay, so this curve goes shooting up, okay. Then what it does on the other side, it does the sort of flip symmetrical part, okay, because we know at tan 120 we're at the negative side, 1.73, so what it does here is it curves like that. Not the best curve in the world, right enough, but it goes like that. Then it repeats itself, it goes shooting up there, and it goes back down to there, okay, so you can see it does have a symmetrical pattern. However, the key thing is it doesn't have any points at 90 or 270. You see my graph does not touch them, okay. The correct word for that, if anyone's interested, it's part of the advanced higher course, believe it or not. They're called asymptotes, okay. They're part of graphs that do not have a solution, okay, but we can still use them to work out what happens to the graph just before and just after, okay. So that's why tan graphs are complicated and they're not easy to draw, and all likelihood you won't be asked too much to draw them, okay? But it's important that you spot what the key points are for a tan graph as well, okay? We're going to write them down, okay? So talking about a tan graph, the main one is actually, from difference from sine and cos, is actually its period, okay? So a tan graph starts there, curves and goes all the way up, and then stops. We then end up being on the negative side, it curves and it goes back down to 0 there. So that's actually its full cycle, because you can see it repeats itself. So its period this time is actually not 1800, let me start again, is actually 180 degrees this time, okay? Because if you look at the whole from 0 to 360, there's actually two graphs in there, there's two parts, there's two cycles of a tan graph, okay? It repeats itself already in there, okay? So period is 180 degrees, okay? Main thing is though about tan graph, okay, so there is no solution, okay, so there's no solution at 90 degrees and 270 degrees, okay. Now one thing that's quite good to know about it is that it starts at 0, okay, that's where a tan graph starts, okay. Now you'll notice I've not spoken about maximum minimums because, believe it or not, there is no maximum for a tan graph, okay? What a tan graph does, and it just, the closer you get to 90 without actually hitting it, the taller it gets, okay? So it's not got a maximum. And also the minimum is the same, so just after 90, okay? So the minute you're just after 90 degrees, it has got a minimum, okay? And it is not got, so it's not got a specific minimum, it's just at the lowest point, but you can always keep going lower and lower the more numbers you include in your calculator, okay? But these are key points about these graphs. Your task today is going to be, once you have got these drawn and you've understood what each graph looks like, is to then see, okay, if we add a number at the front of them, what does that mean for its values? Okay, so for example, maybe not y equals sine x, but what happens when it's y equals 2 sine x, okay, and so on, and we're going to keep changing them slightly, but the key thing is that you know what the basic graph looks like for each, okay, so that you can draw, okay. Once you know the key points here, you do not need to always sketch. You do not always, you do not always need to draw out a table to get all these values again. These are just so that we knew and could explore what type of curve or straight line we were going to get, and it turned out it was curve, okay? But the main points to know are what happens at 0, 90, 180, 270, and 360, and that's for each of the graphs here, okay? Those are the key points for all three graphs. Okay, thank you.